In this episode, we're going to use the ECS Wizard to set up an ECS environment to manage our Docker containers. From the Amazon Web Services console, go ahead and click on EC2 Container Service. If you've already used the ECS environment before, then you're going to find existing things on here. But what you can do to launch the wizard is you can go to this first run URL, which I'll make sure will be available to you. And that's going to go ahead and launch this ECS Wizard for us. The ECS Wizard first prompts us for two options. So first, do we want to deploy a sample application onto an Amazon ECS cluster? We're going to leave this checked so it will create the environment for us, as we can see the auto-scaling groups and everything that we need. And then the second one is, do we want to store container images securely within Amazon ECR? Amazon ECR is the ECS container repository, or EC2 container repository, and it's like your private Docker hub. For now, we're going to leave this unchecked, and we'll come back to that in a future episode. When you're ready, press continue. The ECS Wizard runs three primary steps. First, we create a task definition. That task definition defines the Docker containers that we want to run and the configurations for those containers. The second step configures an ECS service, and an ECS service is the abstraction that manages our task definitions. It starts and stops Docker containers and registers them from our Elastic Load Balancers. And then finally, it has us create the cluster, and the cluster is the component that owns the EC2 instances upon which all of our Docker containers are going to run, and then houses those services. So for this example, we are going to create a task definition that manages an Nginx web server. So let's go ahead and give it a name. So I'm going to name my task definition Nginx task definition. Then I need to give the container a name. So a task definition can have multiple containers. I recommend you typically only run one, but you could have multiple containers. So in this case, we need to give the name of the container that we want for this one. So I'm just going to call this one, if I spell correctly, Nginx container. Next, image. So what is the Docker image that we want to run? If we look at Docker Hub, we see that Nginx is one of the official repositories, so we don't need a namespace for it. And if we omit the version, we'll get latest, which will be perfect for our scenario. So let's just say that we want to run Nginx as our image. Next, it asks how much memory do we want. So by default, it says 300 megs. Let's go ahead and say 256. It's however much memory your container happens to need. Next, port mappings. So if you have a particular port that's running on the container and you want to expose it differently on the host, then you can do that mapping here. So if you had, for example, Tomcat, which runs on port 8080, and you want to map it out on port 80, you could set the container port to 8080 and the host port to 80, so it would handle that port mapping. If you have multiple ports, you can add additional port mappings. The last thing I want to do on here is click on this advanced options. So the advanced options have quite a few important things from a Docker perspective, but the one I want to mention first is the CPU units. So if you see this call out, the number of CPU units to reserve for the container. A container instance has 1024 CPU units for every CPU core. The thing to identify here is that when we run our EC2 instances and we've got our containers running on them, each core has 1024 CPU units. So if I take this 10 that's on here and I say I want 256 CPU units, then that means I want a quarter of a CPU. And you can adjust this according to your needs. As we look at the rest of this environment section, most of this is stuff that should probably be in your Docker file. So the entry point, the command you want to execute in a working directory. But one that is really important is this environment variable section. So you can add multiple environment variables, and this is a good way to manage your containers like you're managing microservices, injecting things like, hey, the URL for my database is right here. So you can add those in. The other common thing that's done in here is if you come down to volumes, if you wanted to mount an external volume, you can do so right here. But for now, for this example, we're going to leave the rest of the configurations as default and hit update. So now we've got an Nginx task definition that contains one container, which would be an Nginx container, and that one is going to launch the Nginx Docker image. That image, we're going to allocate 256 megs of memory, and we're going to allocate a quarter of a CPU core to it. And we're going to expose port 80 as port 80. So when you're ready, press next. The second step in the wizard is to configure a service. So again, the ECS service is going to be the abstraction that manages your task definition, which means it manages your Docker containers. So let's give our service a name. So in this case, I'm just going to call it Nginx service. And then it asks us how many instances or number of tasks do we want to run. So remember, a task is a Docker container instance. So let's set this one to 2. Running 1 wouldn't be so interesting, for example. So we'll tell it that we want to run 2 instances of our Nginx web server. And then it gives us the option to configure an elastic load balancer. So the elastic load balancer, by default, it says no ELB, but we want one. So if you remember, we named our container up above in the previous step, Nginx container. So it's proposing an Nginx container on port 80. So I'm going to go ahead and choose that. And so now this is going to create an elastic load balancer, or ELB, for us. And it's going to handle, by our configuration here, an HTTP protocol. And it's going to listen on port 80. We can configure a health check if we want to. And then next down here, we want to give that ELB an identity and access management role. So remember that the service that we've got needs to register and deregister instances from the ELB. So we need to give it a role. And if you're running this for the first time, you won't have this. So I'll just tell it to create a new one. And when you're ready, press next. Okay, the third step is to configure the cluster itself. So we have to give the cluster a name, which default will work, but I'll just call this Nginx cluster. What type of EC2 instances do we want to run? And you can see that we've got quite a few we can choose from. In this case, I'm just going to leave it as a micro instance, run it on the cheap. I think that's got 1 GB of memory and a single core. And then next it says number of instances. So how many EC2 instances do we want to run? And there's a little warning here that says insufficient container instances for desired task port mappings. What this means is that each one of the services we configured has a container, a Docker container that's exposing port 80. We're asking to run 2 of those. And if we have 1 instance, then we can't run, can't have 2 port 80s. So in this case, I can change it to 2, but I'd recommend that you change it to what I'll just say n+1. So if you have, in our case, we've got 2 instances of our service, then we want to have 3 instances of EC2 that are running those services. And the reason being is when we get into rolling deployments, the algorithm that ECS uses to roll to new versions is that it starts a 3rd instance and then turns off one and then starts, so it does it kind of in that rolling fashion. So you need to have at least 1 more or the rolling deployments won't work. So let's continue on here. So from security groups, so how do we want our all these EC2 instances to be accessed? Well, these are web servers. We're going to put them on the internet and say they can be accessed from anywhere. And then finally, we need to set up the container instance IAM role. So the container instance itself, it's an EC2 instance, but it's a special one. The AMI that it's running has 2 additional pieces from above and beyond the operating system. It has a Docker engine that'll run the Docker container, and it also has the ECS agent. And the ECS agent needs permissions to be able to talk back to the cluster, and that's what this role is for. So if you haven't done this before, it should just give you the option to create a new one, so I'll just take that. And when you're ready, press Review and Launch. So here's a summary of what we're going to do. So we've got a task definition, and the task definition names didn't take when I did it, but hey, task definition name is Nginx, the container name is Nginx, the image name is Nginx. This Docker container is going to run with 256 megs of memory and map port 80 to port 80. And as we also can see, if we expand this JSON definition, we'll see that we're also requesting 256 CPU units, which again is a quarter of a CPU. The service we're creating is named Nginx service, and it's going to be running this container. You can see the container name and port 80. It's going to be running 2 instances of the container. We're going to create a new IAM role, and then we're also creating the ELB that will balance between this Nginx container on port 80 using an HTTP protocol. Finally, we've got our cluster. In our cluster, we've requested 3 EC2 instances of type T2 micro, and we're making it available to the world, and we're exposing port 80 so that we can get to our Nginx services. Now, if you had multiple ports and you wanted to provide access to them, then you would have added those in the cluster configuration before. And then finally, we're going to create a new IAM role. So if I press launch instance and run service, now this is going to go through and create each one of those things for us. So I gave it just a minute to run, and so let's see what it did. So first, create service or create cluster. So it created the Nginx cluster, it created the task definition, it created the ECS instances, which are the EC2 instances running the Docker engine and the ECS agent. So it created those inside the cluster, and then it created the service. And you can see if you scroll down through here, we had a CloudFormation template that was created, and we saved to our account, so we can look at that to recreate this environment. It created an internet gateway and a virtual private cloud to manage our environment. It created the ELB security group. It also created an ECS security group. It created the auto scaling group for those instances. And then it finished up by creating the actual ELB and the container service itself. So as soon as you're ready, you can click on View Service to continue. So here we are. We've got our service. So this is our Nginx service that we created. It's inside of the Nginx cluster. We can look down and see our tasks. So we were running 2 instances of the Nginx task, which if we kind of pan over under our task definitions, I apologize, it took the wrong name, but Nginx, that's the one that it's running. Drill back into my service. So it's running 2 instances of my tasks. I can see here's my Elastic Load Balancer. So let me go ahead and open this one in a new window so that we can actually jump over to the EC2 console or the EC2 dashboard. Here is our ELB. So if I grab this oh so pretty name and open up a new browser and go to port 80 on there, I will hopefully see Welcome to Nginx. There we go. So I've got the service. The service has got the load balancer. If I look at the cluster itself, I will see under this ECS instances, here are the 3 instances that it created. Remember, I recommended that you create 3 instances instead of 2 so that we can do rolling deployments. Again, time for another episode. We can see on here that of these, we have 768 available CPU units on 2 of them. So remember that our container is using 256, so that's where those went. And then we also have 739 megs of memory. So this shows that if we had other container instances that we wanted to run, which would be wrapped by their own ECS services, they could be run on these machines right next to the ones that are running. The only limitation we have is that we cannot use port 80. So let's take a brief look at what we've got inside of the EC2 environment. So let's go back to the AWS console and click on EC2, and we'll see now what it did for us. So I have 5 instances running, 2 of which are my web server and my MongoDB. But other than that, I have 3 ECS instances here. And you can see they are T2 micro, and we can see also, if we look around here, we'll find the auto scaling group for them. But I can drop down here to the auto scaling group to see exactly what I've got. So I've got an auto scaling group that can have a minimum of 1 server, a maximum of 3, and it desires 3 right now. If I look at my instances, I will find all 3 of those in here. So these will be the 3 EC2 instances that we have up here. The final thing we might want to look at is the load balancer. So we're going to have 1 single ELB that will be balancing port 80, and it'll be balancing it between 2 different instances, and that will be these 2 EC2 instances that are hosting my Docker containers, or those Nginx containers. So one important thing to note about this configuration and how it's been set up is that the ELB is disconnected from the auto scaling group. The auto-scaling group is managing the EC2 instances inside the ECS cluster, whereas the ELB is managing the services. So the Docker, or I should say balancing between the two different EC2 instances that are hosting my Docker containers. So that's just an important thing to note. So as we wind down this episode, I'll leave you with some time to play. But if you want to clean up, something that they've done, which is really nice in this now, is if I come over to my Nginx cluster that I created and click the X key and say I want to delete this cluster, which would delete the CloudFormation stack, which would mean all of the EC2 instances and everything, it will go ahead and clean up your environment for you. So I'm going to do this, and I'm going to leave you to enjoy, and I will see you on the next episode. Thanks.